Dear students, welcome to the video lecture of object-oriented design. So far, we discussed about the object-oriented analysis. So in this video lecture, we are going to discuss about the object-oriented design. This is the second step followed by the object-oriented analysis. Object-oriented design process and design axioms. Design axioms is a set of rules to carry out the design are known as the design axioms. During the design phase, the classes identified in the object-oriented analysis must be revisited. We have to revisit all the classes which are identified in the object-oriented analysis with the shift in focus to their implementation. New classes or attributes and methods are to add at for implementation purpose and user interface. New classes, attributes, and methods are added for implementation purpose and user interface. Time spent in the design has a great impact on overall success of the software development project. Time spent on the design has a great impact on overall success of the software development project. So the design is a very important activity. Good design always simplifies the implementation and maintenance of the project. Good design always simplifies the implementation and maintenance of the project. So design process contains three steps. Object-oriented design. The first step is apply the design axioms to design classes, their attributes, methods, association, structures, and protocols. It means the first step speaks about the business layer, classes and objects. Apply the design axioms to design the classes, their attributes, methods, associations, structures, and protocol. It contains a lot of steps, sub-steps. 1.1, refine and complete the static UML class diagram. That means object module. Refine and complete the static UML class diagram by adding the detail to the UML class diagram. This step consisting of the following activities. This 1.1 contain a set of sub activities. The first one, refine the attributes. Refine the attributes which are identified during the analysis phase. Second step, design the methods and protocols by utilizing a UML activity diagram to represent the methods algorithm. So design the methods and protocols by utilizing UML activity diagram, which is already carried out in the analysis phase to represent the methods algorithm. Next step, refine the association between the classes. If required, refine the association between the classes, the relationship between the classes. Next step, 1.1.4, refine the class hierarchy. That means superclass and subclass relationship and design with the inheritance if required. So refine the association, refine the class hierarchy if required. So iterate and refine the process. This is the first step. Apply the design axioms, design the classes, their attributes, methods, associations, structures, and protocols. Second step, design the access layer. So create a mirror classes. That means that every business class identified and created, create one access classes. The second step is design the access layer. Access layer means the set of objects in this layer which is responsible for to interact with the database design. Create mirror classes for every business class identified and created. Create one access class. So on second step, define the relationship among the access layer classes. So define the relationship among the access layer classes. Third step, simplify the class relationship. The main goal here is to eliminate the redundant classes and structures. Simplify the class relationship. The main goal is here is eliminate redundant classes and redundant structures. So it contains the two steps. So two sub steps. The first one is redundant classes. That means that if two classes they are having the same purpose, these classes are known as redundant classes. Do not keep the two classes that perform similar translate request, translate result activities. Simply select the one and eliminate the another. Second step, method classes. Revisit the classes that consisting of the only one or two methods. For example, if the classes consisting of only two or method, for holding one or two method, there is not necessary for a class. So you have to see to that whether you have to able to move the method to some other classes. That means that okay, if the class will be eliminated or combined with the existing classes, method will be moved to some other classes and this class will get eliminated. So iterate and refine. This is the design the access layer. So create the mirror classes for every business class. You have to create an access class and define the relationship among the classes. Simplify the class relationship. It contains two steps. Redundant classes, if the two classes which is having a same translate request and results, keep on eliminate other. Method classes, if the class is responsible for one or two methods, ensure that the class will combine with some other classes and method are moved to some other classes, then this class will get eliminated. Iterate, and first step, iterate and refine. The next step, design the view layer classes. So view layer means the layer contains a set of objects responsible for the user interface is known as a view layer. It contains the two type of activities. One is macro level user design the macro level user interface, identifying the view layer objects. Second one is design the micro level user interface. We are going to discuss in detail about the view layer, the portion view layer about the macro level and micro level user interface. Design the macro level user interface, identifying the view layer objects. Design the macro level user interface, which include the two activities. Activity 1, 3.2.1, design the view layer object by applying the design axioms and corollaries. The second step, 3.2.2, build a prototype of the view layer interface. So design the view layer object by applying the design axioms and corollaries. Second step, build a prototype of the view layer interface. Third step, test the usability and user satisfaction. Test the usability and user satisfaction. You have to check the usability and user satisfaction. Okay, you have to by the test, you have to check that how extent the user are satisfied, and iterate and refine. So up to this, the third step should be iterate and refine. So the step 4 is iterate and refine the preceding steps. What are the preceding steps? The first one is apply the design axioms to design the classes, their attributes, methods, associations, structures, and protocol. Second step, design the access layer. Third step, design the view layer. Okay, so all the three steps should be, we have to iterate and refine the preceding steps, reapply the design axioms, and if needed, repeat the preceding steps. The next one is we are going to discuss about the object-oriented design axiom. So what is an axiom? By definition, an axiom is a fundamental truth that always observed to be valid. It's a fundamental truth that always observed to be valid and for which there is no counterexample or exception. Okay, if the axiom means that is valid, that's all. Okay, there is no counterexample or exception. Explain the axioms maybe explain the axioms may be hypothesized from large number of observations. So explain that axioms may be hypothesized and formed from the large number of observations by nothing by noting the common phenomena shared by the classes. Second one is theorem. Theorem is a proposition that may not be self-evident but can be proven from the expected axiom. Theorem is a proposition that may not be self-evident but can be proven from the accepted axioms. It therefore is equivalent to law or principle. Theorem means it's a proposition. That means a law or principle. It is not be self-evident and but can be proven from the expected axioms. Corollary is a proposition that follows from an axiom or another proposition. Corollary is a proposition that follow from an axiom or another proposition that has to be proven. So this is object-oriented design axioms. This object-oriented entire design process is given in the diagram. The first step, design the classes, methods, attributes, and association, and then apply the design axioms, refine the UML class diagram. The next step, design the view and access layer and prototype. The next step is user satisfaction and usability test based on the use cases. So first you have to focus on the design the classes, methods, attribute, association. You generally focus on the business layer. Apply the design axioms, refine the UML diagram. Then next, design the view layer and conduct the user satisfaction and usability test is a continuous test. Okay, and as well as it is an iterative process, as well as we are able to move between the phases. Okay, we move between the phases, various phases of the design. That is the advantage of the object-oriented design. Next, we are going to discuss about the type of axioms. The axioms are two types. One is independent axiom that says that maintain the independence of the components. Each software component should be independent. Second, information axioms minimize the information content of the design. So minimize the information content of the design is the axiom 2. So we will discuss in detail. Axiom 1 state that during the design process, as we go from the requirement and the use case to a system component. So during the design process, we have to go from the requirement and use cases to a system component. Each component must satisfy the requirement without affecting the other requirement. Each component must satisfy the requirement without affecting the other requirement. Axiom 2 is concerned with simplicity. The best theory explains the known facts with the minimum amount of complexity and the maximum amount of simplicity and straightforwardness. Axiom 2 is concerned with simplicity. The best theory explains the known facts with the minimum amount of complexity and maximum amount of simplicity and straightforwardness. So this is the axiom 1 and axiom 2. There is a principle that's known as axioms raise a rule of simplicity in object-oriented design. That means that the best design usually involve least complex code, but not necessarily fewer number of classes or methods. There is no need. Okay, this code complexity should be minimized, and it means that there is no there is no need to create a fewer number of classes or methods. Minimizing the complexity should be the goal because that produces the most easily maintenance and enhanced application. So minimize the complexity, produce the most easily maintained and enhanced application. In object-oriented design, the best way to minimize the complexity is to inheritance. In object-oriented design, the best way to minimize the complexity is to use inheritance and systems built-in classes, and to add as little as possible to what we have, what already is there. Next, we are going to discuss about the corollaries. Corollary means a proportion that follows from an axiom or another proportion that has to be proven. So generally, corollary follow the axioms. So we are having a 6 corollaries. Corollary 1, 2, and 3 are based on the axiom 1 and as well as axiom 2. Corollary 4, especially it's based on the axiom 1. Corollary 5 and 6 are based on the axiom 2. So we are going to discuss about the what are the each corollary states. Corollary 1 is uncoupled design with a less information content. That means that highly cohesive objects improve the coupling. That means that highly cohesive object, the object which is self-sufficient or self-contained, are known as a cohesive objects, which improve the coupling. Coupling stands for the information sharing between the objects is known as a coupling. If the information sharing between the objects are high, then the coupling is high. The information sharing by interconnection or information sharing between the objects are low, then coupling is low. If the object is cohesive, okay, self-sufficient, selfly properly connected objects, that improves the coupling. That means only minimum amount of information is passed between the objects. Second one is single purpose. Each class must have a single and clearly defined purpose. This is the corollary number 2. Corollary number 3, large number of simple classes. Keep the classes simple allows reusability. Keeping the classes simple allows the reusability. If the class is simple, then we are able to reusable. That's why you have to keep the large number of simple classes. Okay, then a small number of complex classes. We have to prefer large number of simple classes. Strong mapping. There must be a strong association between the analysis object and as well as the design object. Strong association between the analysis object and as well as the design object. Third, that's standardization. Promote the standardization by designing the interchangeable component or reusing the existing class or component. Standardization. Promote the standardization by applying interchangeable component or reusing the existing class or component. That is one of standardization. So when you design a component, you have to ensure that you have to design that the component should be reused in some other project. Design with inheritance. Common behavior must move to superclass. Common behavior methods will be moved to superclass. Specific behavior will be moved to the subclass. The superclass subclass structure must make a logical sense. Okay, these are the 6 corollaries and 2 axioms and 6 corollaries are discussed. We are going to discuss each corollary in detail one by one in the forthcoming video lectures. Thank you. Thanks for watching the video lecture. Thank you.